Actually, I have two more here. So let's try our function y equals x plus 1 over x. And again, the directions are find all relative extrema. All right, so first up, points of discontinuity. Any places where we would be dividing by 0 or taking the root, an even root of a negative number. So certainly, I have an issue here with if x is 0. So I have a discontinuity at x equals 0. And in fact, I will have a vertical asymptote there. Number 2, derivative. Okay, derivative of x is 1. And if I rewrite this, I can use the power rule here. I'll bring negative 1 x to the negative 2. So this is 1 minus 1 over x squared is our derivative. Okay. Number 3, I want to find out where this is 0 and where this is undefined to find our critical numbers. Okay. So that would mean 1 minus 1 over x squared is equal to 0. That would mean 1 would have to equal 1 over x squared. And for that to be true, 1 over x squared would have to be 1. So we'd have to have 1 over 1. It means x squared would have to be 1. It means x is 1, or negative 1 would work. All right, 1 minus 1 over x squared is undefined at x equals 0, but the original function is not defined at x equals 0, so this is not a critical value. Okay, we'll use the fact that we do have a discontinuity, and we'll use the fact that we've got two critical numbers for our chart. Okay, so let's go ahead and make our chart. And we're going to have 4 subintervals because I have 3 breaking points, so it'll break it into 4 parts. All right, so we've got y prime, our test value, our sign, and whether it's increasing or decreasing, right? Okay, so our first, let's see, our leftmost x value here that we're going to consider is negative 1. So negative infinity to negative 1, and that's a critical value. Then from negative 1 to 0, 0 to 1, and from 1 to infinity. Okay, now I'm going to point out here because I want to keep in mind that x equals 0, that's a point of discontinuity. So I want to point that out in my chart so I remember that. Okay, so test value, something between negative infinity and negative 1. Negative 2 will work. Something between negative 1 and 0, negative 1/2. Something between 0 and 1, positive 1/2. Something between 1 and infinity would be positive 2. All right, so let's see. We've got 1 minus 1 over x squared. So we've got 1 minus 1 over negative 2 squared, or 1 over 4. So that would be positive. We get 3/4. 1 minus 1 over 1/2 squared. So that would be 1 over 1/4. So it's really 1 minus 4, right? Divide by a fraction, flip and multiply. 1 divided by a fraction would be reciprocal and multiply. So 4 over 1 times 1. So that would be negative. We get the similar situation here with 1/2. 1 divided by 1/4. So 1 minus 4 would be negative. And then 1 minus 1/4 for the last one would be positive. So I'm increasing and decreasing. And I have that break in my graph at x equals 0 because I have a discontinuity. And then I go from decreasing to increasing. So where do I have, so if we sort of sketch this out very roughly, I have those two things going on there with that break in the graph at x equals 0. So I have a relative max at x equals 1. I'm sorry, at x equals negative 1, and a relative minimum at x equals 1. The relative max value is y equals negative 1 plus 1 over negative 1, which is negative 2. And the relative minimum value is y equals positive 1 plus 1 over 1, which is positive 2. So if we were to graph this, this has a high point at negative 2, or I'm sorry, at x equals negative 1, and it's at that high point is negative 2. And a relative minimum at x equals 1, and that value is 2. You might say, well, wait a minute, how can a relative minimum be higher than a relative maximum? Well, if you think about the graph, what this might look like, this in fact, we're going to discover looks something like this. The axis going through like this. And so you can see where the relative maximum would be below the x-axis and relative minimum would be above. All right, let's try one more. That is our function g of t is equal to t minus 1 to the 1/3 power. Right. In other words, this is the cube root of t minus 1. So first off, discontinuities. Well, I'm not dividing by 0, so I don't have a rational function. And I have an odd root, and I can take odd roots of negative numbers. For example, cube root of negative 8 is negative 2, so that works. So this has no discontinuities. Number 2, find the derivative. G prime 1/3 t minus 1. Right, I'm not done with the outside yet, so the inside stays the same using the general power rule. Subtract 1 from the exponent, so negative 2/3 times the derivative inside, which is 1. So if I want to take a look and see what this really looks like. This is 1 over 3 times t minus 1 to the 2/3. So that's what that looks like. Or in other words, 1 over 3 times the cube root of t minus 1 squared. All right, step 3. Where is g prime 0? And where is g prime undefined? Okay, so that means where is 1 over 3 times t minus 1 to the 2/3? 0. Well, we said that's when the numerator is 0, but that can't be 0. 1 can't be 0. So the derivative is undefined when the denominator is 0. That's 0 when what's under the radical here is 0, so that's when t minus 1 is 0. That's when t is 1. Now, so here's a case where we don't have any place where the derivative is 0, but we do have a place where the derivative is undefined. So I have to ask myself, is that a critical number? In other words, can I plug that number back into the original function? Is it a point of discontinuity or not? Well, original function had no discontinuities, so this number is in fact a critical number. It's a place where the derivative is undefined, but yet the original function is defined there. So we do have a critical number. All right, so we have just that one, so let's make our chart and see if that's going to be a relative minimum or a relative maximum. And let's see, I didn't quite leave myself enough room here. I think we can fit it in right here. We're only going to need 2 intervals, right? 2 subintervals. And so we've got g prime, the test value, the sign, then we need, is it increasing or decreasing? Okay, and let's see, we only have one critical number, so that would be from negative infinity to 1, no points of discontinuity, so just these 2 subintervals. So one test value from negative infinity to 1 would be 0, one from 1 to infinity, we pick 2. Okay, so if I plug that in, I get, what do I get here? Let's remind ourselves where our derivative is. So that would be 1 over 3 times, let's see, 0 minus 1 would be negative 1. Square that would be positive 1. Take the cube root of positive 1, that's 1. So 1/3, 1 over 3 times 1, which is certainly positive. And then the next one is plug in 2, so it would be 1 over 3 times, let's see, 2 minus 1 is 1. 1 squared is 1. Cube root of 1 is 1. So that is also positive. So this is increasing and then increasing. So this, in fact, has no relative extrema because I don't have a change in direction. Okay? And if we were to draw this, this would look something of what it would look like. Look something like this. Again, you can plug these into your calculator, get a visual confirmation of your work. All right, that's all we have done for increasing and decreasing functions and then relative extrema in the first derivative test.